You can try and fill in this box, whether it's inside or outside. Anyone know something we can fill out? Okay. X would have to be on top. How do you know that part? 4 times x is 4x. What's something else you can fill out? 6 times 4, so the top right. Okay.
And then 6 on the outside.
6 has to be on the outside. How come? Okay, and then what would be in there? Okay. What about this one? Ooh, why is it x squared? X times x. What do you do with x squared when you multiply? Add them, because that has an exponent of 1, that has an exponent of 1. Just refresher on those rules. What would be in this top right box?
Yes.
What would be in this bottom left box? Yes. And what about here? Okay, cool. I'm glad. Was that hard? Wonderful. Friday. Friday. We did problems like this. Look familiar? Okay. Did anyone start catching on to like a trick of like where x squared would always be, where your x's would always be, and where your 1's would always be? Where? Okay, so 1's would always be in the bottom right. Where would the x squareds always be? Top left. And then what about the top right and bottom left? They were always our x's. So we kind of have this split. What would this answer be? X squared. What's in this spot? 3 x's. What's in this spot? Negative 4x. And what's in this spot? Negative 12. Right? We were doing all of that on Friday. Well, how can I write out what was along the top? Like, what is showing right here? X. And then 3 positives, so plus 3. What was along the side? X and negative 4. And then this is our answer, right?
Yeah.
What would the final answer be? What were we combining together?
The like terms.
The x's, the like terms, right? So x squared minus x minus 12. This kind of looks familiar to me. It kind of looks like what we just did here. Because it is. This is showing x plus 2 times x plus 8. What would our final answer be on this? Plus. Alright, so now your notes. We just did this problem that is at the very top of your notes. X plus 3, so x plus 3 along the top. X minus 4 along the side. So it's still that same concept of something along the top and something along the side. It's just not drawing the picture. And then it's our columns times our rows. So what's x times x? What's x times negative 4? What's 3 times x? And what's 3 times negative 4? So instead of making it where it is pictures, we're just breaking it down and making it the number part instead. Combining terms. The top left is x squared. Is anything combined with that? No. X, 3x, and negative 4x give you negative x. And then is anything combined with that negative 12? Ta-da! That's our general setup pretty much every single time. So if we look at another problem, one goes along the top, one goes along the side. So this guided practice. 2x plus 5, or 2x minus 5 times x plus 6. What would you get in the top left corner? 2x squared, wonderful. What about the top right corner? Negative 5x. What about the bottom left? 12x. And then the bottom right? Negative 30. Columns times rows. Final answer needs to have the combined like terms. So 2x squared is out in front, because we're going to write in descending order. Our x's combined, so 12x and negative 5x. What's 12 plus negative 5? 7. And then minus 30. Okay. Let's try number 2. One goes along the top, one goes along the side. So 2x plus 5, 2x minus 5. What's in the top left? 4x squared. 5 times 2x. What's in the top right? Okay. 2x times negative 5. What's in the bottom left? Negative 10x. And then 5 times negative 5. What's in the bottom right? Negative 25. Inside is where our product is, where our answer is. So we're combining anything that has a like term. 4x squared is out in front on its own. Our two top right and bottom left are always our like terms. What do we get when we combine those? 0. So we don't need to write anything with x. They just cancel out. And then minus 25. Okay. Go ahead and do the bottom 2. And then I have 2 that I want you to add in on your paper. How is this one that you're adding on? How is that different? Okay, it's a 2 by 3. Everything else we multiplied has been 2 times a binomial times a binomial. How can we set this up then? Yeah, just make the, instead of having it be a nice 2 by 2 square, make it something that is 2 by 3. So 2x minus 5, of course, negative x squared plus x plus 12. So what's going to be the top left column? Negative 2x cubed, because x squared times x and that's cubed. If we go on the bottom left, that's negative x squared times negative 5. 5x squared is negative times negative 5. Top middle, x times 2x. 2x squared. Bottom middle, x times negative 5. Top right, 12 times 2x. 24x. And then bottom right, 12 times negative 5. Negative 60. Okay. It's the same kind of pattern though. When we have this box, it's the same setup. The top left is usually always the term with your highest degree, highest exponent. So negative 2x cubed. And then the diagonals are usually the ones like bottom left and top right are usually the ones that combine. So 5x squared plus 2x squared, what does that give you? Add them. Combine them. 7x squared. And then 24x and negative 5x. What does that give you? 19x. And then minus 60. Your constant, meaning the number without the variable, is usually always the bottom right. Yes?
What is the number in the top square? Cube and not a square.
Because what's x squared times x? Right? X squared would mean x times x, so times x. So x cubed. Okay, so flip over back. Because this setup, what we were just doing, where you draw that box is called an area model. So if we're solving this problem with an area model, one goes along the top, one goes along the side. We have x plus 7, and then 4x minus 2. What would be in the top left of that area model? 4x squared. What would be in the bottom left? Oh, negative 2x. What would be in the top right? 28x, and then what about the bottom right? Negative 14. Okay, you can solve this by the area model all you want. That is perfectly fine. That is a method of doing it. There is also a method where you just don't have to draw it, but it's the same idea. That one we're calling double distributing. So it's still this, but it's where you don't have to draw that box. What does distributing mean? Oh, thank you. What does it mean to distribute? Yeah, but if we are double distributing, that means you have to distribute more than just one time. Double distributing means you're multiplying each term in that first parentheses with each term in the second parentheses. So what's x times 4x? X times negative 2. Negative 2x. 7 times 4x. 28x. And then 7 times negative 2 is negative 14. What do you notice about what I just wrote in pink? Look at what I put in green.
It's the same.
It's the exact same thing. It's just, do you like that visual of having a box where you're filling things in, or can you just do it as one string as that double distributing? It is up to you. You're always multiplying. It's each term and each parentheses being multiplied. Yes, we are not done yet. Neither of these are complete. Both of them are still missing. Like, we haven't combined. We haven't written our final answer for either one yet. But it's the same amount of steps. If we're combining, 4x squared doesn't combine with anything. Whether it's the area model, those combining, or if it's the double distributing, those combined. What's the term, or what's the variable, the coefficient for x? What's negative 2 plus 28? 26. And then minus 14. So that is your answer. Now, whichever method you like better, I don't care if you do both or you do whichever method you like. I don't care if you change up which method you use. Okay, so what I want you doing. So on the one underneath the rectangle column, talking about a roof truss, it's in the shape of a triangle with a height of x feet. And a base of 6x minus 8. So we have to figure out the area of a triangle. How do you get the area of a triangle? Base times height divided by 2, 1/2 base times height, whatever it is. One of the steps we're going to have to do is multiplying the base times the height. So that means we're multiplying x times 6x minus 8. Well, that one's just a term on the outside, so we might as well just distribute it. You can make the box if you want to. It'd be a 2 by 1 box. What's x times 6x? 6x squared, and then what's x times negative 8? Negative 8x. Now, is that my answer? Why? What do we still have to do? Divide it all by 2. Need half of everything. Am I going to be changing the exponents? No, just the coefficients. So what is my final answer going to be? Okay. The one right underneath it, the one that says landscaping. I want you reading that and drawing a picture of it and trying to set it up with your table first before we start going over it. A picture will help. Draw. So this is the garden, and then they're putting a uniform walkway, a uniform width walkway. What does a uniform width mean? It's all the same, like it's all the same width around it. It says around, so we have this walkway going around. You are asked to find the area of the garden and the walkway included. Meaning you need to, 15 and 20 are not your length and width anymore. This whole thing is your width, and this whole thing is your length. Well, that means the 15 is right here. So we know 15 is good. But what is this little space at the top and the bottom? The walkway. Do we know the length of the walkway?
No.
What do we usually use if we don't have one? Okay. So what would that width now be? 2x plus 15. Because right, we're just combining that whole thing together. So then what's the length going to be? The 20. 20 takes up this spot though. This is still x, so 2x plus 20. So now we have to,
Oh wait, no, we're just.
we're finding area, right? So what do we need to do to find the area of that?
2x plus 2x plus 1.
Correct. Okay, go ahead and find that area now. What is the simplified answer for the area? 4x squared plus 70x plus 3. Okay, wait, one last question. Last question. Can anyone tell by the just by glancing, Bill made an error. I want you to start noticing something. Can anyone tell right away what the error is? Yes, ma'am. Yeah, it came at the very end. The constants multiply, so what should that be? That should be 19, not 20. What did Bill do instead? Added instead of multiplying. Well, we would have x squared plus 19x plus x plus 19, right? So the 20x is good. It's just that constant.